Hello, welcome back. Here is Ali Talabi, and this is the second lesson from Module 11. In the first lesson, we talk about the return, and we call that actually visible half. Now we're going to talk about the risk, which is called the hidden half. So in this lesson, we'll talk about the meaning of the risk. What does it mean? We mentioned that there are several ways we can measure the risk. So we'll talk about the variance, standard deviation, CV or coefficient of variation, and finally value at risk. And we'll wrap up by looking at historical risk and return of the markets, capital markets, by looking at different sectors. So let's start our lesson. So when we talk about the risk, what does it mean? So if I tell you that for sure tomorrow you will get $100, so you're confident you will get $100 for tomorrow, it means there is no risk associated. For sure you will get $100. However, when you talk about the investment, most of times we are not talking about 100% confidence level. There always are some probability or chance that you get what you expect, and for sure there is a probability that you won't get what you expect. So this uncertainty portion refers to the risk part. So for example, when it comes to a stock market, based on the historical performance, you might end up having some expected return. So you can calculate the estimated or expected return as we learned in the first lesson. So you can say, okay, it seems that I should expect, based on this probability, I should expect, like, let's say 10% return over the next year. However, there is a chance you will get more than 10% or you will get less than 10%. So the risk here in this case is the probability that you don't get what you expect. Or in other words, the variation from the expected return in the context of investment, it's called a risk. Now, how we measure that? There are several ways we can measure the risk. One of the most common ways is using variance. What is the variance? As I mentioned, that's the common measure of return dispersion, actually. And when I'm talking about dispersion, it means how well your returns are kind of distributed over time. So if you have a higher variance, we're talking about the higher variability, which means there is a higher chance you don't get what you expect. The square root of variance is called a standard deviation. Actually, the standard deviation is more common than the variance, and we also call that volatility. So whenever we talk about volatility, most of times we are talking about a standard deviation. Why we are preferring standard deviation? Because actually we are using the same units as the average when it comes to standard deviation. That's why the standard deviation and returns are kind of comparable in terms of the unit. So that's why we prefer the standard deviation instead of variance. So remember, variance and the standard deviation are two major measures we use to actually estimate the risk of our investment. Now, how we actually or mathematically we use a standard deviation and variance. So here is the formula we use to calculate the variance. So you see the variance is based on the return and the average return. So first you need to calculate the average return or expected return, as we learned the first lesson, and you need to subtract each return under each scenario or under each situation, and then find the square of that difference. And finally, add them all these squared number and divide them by n minus 1. Maybe you say, Ali, why n minus 1? Remember, the reason is most of the times you are using samples to calculate the variance. So you don't have access to the whole population, or you are not using the whole population. So since you are using the sample, we need to adjust for the error or mistakes. So the adjustment here shows by subtracting 1 from n. So n is number of data or samples you have. So n minus 1, you need to divide it by that number. So as you see from the formula, we use Ri minus R hat, which means that It's showing how far you are from the expected or the average return. So if you are further away from the average return, the variance should be the higher number. And as we discussed, if you find the square root of the variance, you will find sigma or a standard deviation. Same argument, higher standard deviation, it means the volatility, the risk is higher. So that's a very common way to measure or calculate the variance. Now let's look at the example. Let's look at this example. Let's assume for the last 4 years, starting 2017, you know that how much return a specific stock provided. So 20%, 25%, minus 10%, and 15% are the annual return for a specific investment, a specific stock investment. Now, simply, you can calculate the average return, and we talk about this. I'm using the arithmetic average return, so I'm just adding all these returns as you see, and which is 50%, and then I'm dividing that by 4. So that's the number of data I have, and I get 12.5%. So 12.5%, that's my annual average return for this investment. So what is my variance and standard deviation? These are the steps. After finding the return, you need to find the difference between individual return and the average return. For example, for 2017, your return is 20%. Your average return is 12.5%. So difference between 20% and 12.5% is 7.5%. We'll do the same thing for the following years. So we'll find 4 differences here. And as you notice, if you add all these differences, the sum of all these numbers should be 0. That's one way you can verify that actually you calculated these differences correctly. And then the next step, based on the formula, you need to find the square of these numbers. So 7.5% times 7.5%, it becomes 0.56%. We'll do the same thing for the following years. So I have 4 squared numbers here. So then find the sigma or the sum of all these 4 numbers. So it gives you 7.25%. And we'll learn to find the variance. You need to divide this by n minus 1. I have 4 data points, data or return for 4 years. So it should be n minus 1, which is 4 minus 1, which is 3. So if you divide this by 3, you will find 2.42% as your variance. And if you find the square root of this number, you will find 15.5% as your standard deviation. So you can say that on average, your data are 15.5% away from the expected return. Again, is this high or low? It depends actually with other investment or opportunities you have. Higher standard deviation, it means higher risk. Lower, it means lower risk. Now, one way you can actually standardize your risk and return is using CV or coefficient of variation. What is CV or coefficient of variation? The CV actually helps you to compare the return with the variance or standard deviation more specifically. So we talk about the return, we talk about the risk, so we learn how to calculate those. If you divide the standard deviation, so if you divide, so let me write it down, a standard deviation by the average return, you can find the coefficient of variation. So it's what it's doing, actually the CV helps you to understand for each unit of return how much risk you are taking. For each unit of return, how much risk you are taking. So in the previous example, we calculated the return 12.5%, we calculated standard deviation 15.5%, correct? So if you simply divide that 15.5% by 12.5%, you get approximately 1.24 as your CV. It means for each percentage of return, you should take 1.24 5% of risk, which is measured based on the standard deviation. Now, the CV is a better measurement. Why? Because it captures the effects of both standard deviation and return. So if you have different investment, let's say I have another investment, so let's call this CV1 and let's call this CV2. I have another investment, another stock investment. I calculated CV and it gives me 1.3 CV. What does it mean? It means for investment 2, for stock 2, you are taking higher risk for the same level of return. So in this case, you should choose 1. Why? Because it provides you lower risk with the given return. So you see the CV now, it's a better indicator of both risk and return. Now, one of the major problems we have with variance in the standard deviation here is that it actually focuses on not just only downside risk, but also it considers the upside risk. What do I mean by that? Now, let's assume that your expected return is 10%. Okay, so that's your expected forecasted return. But actually, after 1 year, you earn 20% instead of 10%. Now, let me ask you this question, and let's be kind of honest on this. Will you consider that as a risk? You earn more than what you expected. Most of investors are more concerned about the downside risk. It means that they're concerned that they will earn less than 10%. So if they earn more than 10%, for sure they become happy, they will be excited. But if they earn less than 10%, which is their expected, they become sad and upset. So that's why we're saying the variance or standard deviation, they don't care about the sign of their return. So they don't care if the return is more than expected, the actual return is less than expected. They capture both sides as the part of the risk. But we are more concerned about the downside risk. So another measurement we can use, which just focus on the downside risk, is called VAR, or value at risk. So it is based on the degree of confidence, and actually VAR gives us a range of maximum loss over a period. So in other words, the VAR helps you to understand what is the probability that you will lose more than a specific number, and that's the number that's the kind of the measurement you are kind of more interested, because it's showing, oh, okay, at a worst case scenario, how much you will lose. So we assume under VAR that there is a normal distribution, and we measure our distance from expected return using a standard deviation. There are two major indicators in VAR: return or expected return and the standard deviation. And for sure, we are going to get help from the normal distribution. So as you see, we know that almost 68% of data are within one standard deviation of the average return, 90% within 1.645 standard deviation of our average return, and you can go up to 99.7% of data which are within 3 standard deviation of average return. This normal distribution argument help us actually to calculate or measure the risk using the VAR. How come? Let's look at an example. So let's assume your expected return is 10%, your standard deviation is 15%. So you calculate it based on the historical data, and we assume the returns are normally distributed. So I can use the normal distribution. So based on the argument we had in the previous section, we can say there is a 90% chance or probability that the next year return becomes between 10% minus 1.645% times 15%, and 10% plus 1.645 times 15%. Remember, this 15% refers to the standard deviation. So that's the standard deviation, and that 1.645 comes from the normal distribution, equivalent to that 90% chance as we discussed earlier. So for sure, you can calculate that 1.645 times 15%. 10% minus that number, it should give you minus 14.675%. and the upper side should be 34.675%. In other words, there is a 90% chance that your return falls between minus 14.6% and plus 34.6%. So if that 90%, what about the other 10%? The 10% probability, it means that your return will be either less than minus 14% or greater than 34%. As I mentioned, in VAR, we are more concerned about the downside risk. So instead of looking at the upper side, we are more concerned about the downside risk. So we can say this is the normal distribution, so there is no skewness, okay? So we can say 5% probability that you will lose more than 14.6%. So that's the type of investment. You can say, oh, 5% probably I will lose more than 14%. Maybe say, oh, that's not huge, so I'm going with that investment. Or maybe for some investors, that's too huge and they want to avoid this kind of stock investment. So again, the argument here is VAR helps you just to see the worst case scenario and decide whether you want to proceed with this investment or no. Now, when we look at the historical information from the markets regarding the risk and return, we notice that small company stocks, they're actually performing better than the large company stocks, and the large company stocks, they perform better than the T-bonds, treasury bonds or government bonds, and they're providing better performance than the T-bills. However, if you look at the historical risk based on the variance and standard deviation, you will see that small company stocks, they have been the most volatile type of investment among these four categories. And as you're moving to the T-bills, the volatility or the standard deviation is going down. What is the conclusion? The conclusion provides us one of the major principles in the investment. The risk and return are moving in the same direction. So if you are looking for the higher return, you should take higher risk. So this is what historical data are telling us. So that's what we learned from the capital markets. That's what we learned from the history of investment. So for sure, if you are open to more risk, the riskier type of investment, so you have the higher chance you can gain more. That's it for today. Lesson 2, Module 11. Next session, we'll wrap up and review some of the major notes, and I will come back with some questions. Thank you very much. Have a wonderful day. Talk to you soon. Here is Ali Talabi.